Good morning. Let me introduce myself. My name is Muhammad Ridlwan. I'm lecturer at Mechanical Engineering Department, University Islam Indonesia in Yogyakarta. And today, I will present my paper which title is 3D printed polymer core and carbon fiber skin sandwich composite as an alternative material for and process for electric vehicle customization. Background. Fuse deposition modeling, or FDM, is one of the most widely used 3D printing technology or additive manufacturing due to its relatively low investment and operational cost. Because it's cheap, reliable, and can create product with high degree of complexity. Composite technology is manufacturing process that is able to create stunning product in terms of strength to weight ratio. The main idea of my research is combining 3D printing technology with composite material. 3D printing technology has advantage in high complexity geometry of product and minimum tooling and labor, but has lack in mechanical property and low production rate. On the other hand, composite technology has advantage in high mechanical properties, but high cost process per unit in molding or installation and labor, and low production rate. The expectation result of this combination is high complexity geometry of products, minimum tooling and labor, and high mechanical property per weight ratio, but has low production rate. So this combination is suitable to customization or product modification. My previous research in 2019, we made aquatic caravan model from 3D printing product which reinforced by fiberglass composite. In 2020, we made research in making unmanned aerial vehicle frame or drone frame using 3D printing, which reinforced by carbon fiber as reinforcement agent. Material and method. In this research, we make 3D printing core from using fuse deposition modeling method and material PLA, polylactic acid and polycarbonate, which infill type is honeycomb, infill density 20%, core thickness we varied in 5, 10, and 15 millimeter, and the orientation of printing 0 degree and 90 degree. And we use composite sandwich skin using two materials reinforcement. This is carbon fiber and fiberglass. For lamination method, we use method hand layup. The combination of these parameters can be seen in table 1. Material and preparation, for specimen. At first, we printing the core using PLA and polycarbonate, and then we reinforce this core using fiberglass and carbon fiber, and then we cure specimen in oven at 73 degree in 1 hour, 30 minutes or 90 minutes. And for testing, we use ISTM C393 for 3-point bending test. And the result can be seen in this graphic. The specific rigidity of the specimen with variation of thickness and printing orientation. In this graphic, we can see 0 degree of polycarbonate carbon fiber and 90 degree polycarbonate carbon fiber. As we can see, that's 0 degree of polycarbonate carbon fiber is higher than 90 degree in specific rigidity. And second result, this is a specific rigidity of the specimen with variation of thickness and filament material. We can see polycarbonate core and polycarbonate reinforced carbon fiber. 0 degree of polycarbonate and reinforced fiberglass, and glass is polylactic acid core. As we can see, the result is it shows that the core of filament material also affect the specific rigidity of the sandwich composite. The polycarbonate core specimen has higher specific rigidity than polylactic acid core. The addition of carbon fiber skin to the 3D printed polycarbonate core did not increase the specific rigidity of the sandwich composite. This is because the increase in the moment of inertia of the bending core cross-section is quite large, but the core weight does not increase significantly. This is a failure mode for 3 specimens. For A, 0 degree PLA GFRP, and B, 0 degree polycarbonate with carbon fiber and thickness 5 millimeter, and C is 90 degree polycarbonate with carbon fiber and 5 millimeter in thickness. As we can see, from 0 degree and 90 degree can be seen in figure below. The orientation of printing the core. In fact, figure A, the core is not able to withstand the combination of shear stress in vertical direction and tensile compressive stress in horizontal direction, so that crack occur. When the crack reaches the skin, the bending stress is much greater than the shear stress. So the crack changes in direction from horizontal direction, from vertical direction to horizontal direction. So the bonding failure occurs. From figure B, polycarbonate core with orientation 0 degree has high stiffness to withstand the bending loads. However, the interface strength between polycarbonate core and carbon fiber skin is not able to withstand the tensile stress that occur, resulting in debonding failure. The polycarbonate core with an orientation of 19 degree in figure C is not strong enough to withstand the shear stress in vertical direction. So the failure is dominated by core shear failure. So conclusion is the use of 3D printing polymer product as a core for sandwich composite is suitable to be applied to equipment or device that require lightweight rigid structure. The specific rigidity property of sandwich composite using 3D printed core is influenced by filament material, core thickness, and the orientation of the model placement on the 3D printed table. Last conclusion is 3D printing process and the composite manufacturing process are relatively slower than other manufacturing process. So, sandwich composite products using 3D printed core are more suitable for modification and customization products. Thank you.